Sometimes the biggest, most incredible scientific breakthroughs are hidden in just a handful of words. Today, we're going to crack open a Nobel Prize citation and unpack the amazing discovery hiding inside. Ready? Let's get into it. Okay, here it is. This is the line. Now, I know, on the surface, it might seem, well, simple. But believe me, this single phrase represents a giant leap in how we understand the world. This isn't just a sentence. It's the answer to a biological puzzle that had scientists stumped for literally centuries. So, yeah, what does that actually mean? What in the world are receptors? And why is finding them such a massive, game-changing achievement? Well, that's exactly what we're here to do. We're going to break it all down piece by piece. Let's start with the part we all get right away. Temperature and touch. These aren't some abstract ideas from a textbook, right? They are the very fabric of our everyday lives. Just think about it for a second. That warmth from your coffee cup in the morning, the feeling of solid ground under your feet, even a cool breeze on your face. These feelings are so constant, so deeply woven into our experience, that most of the time we don't even notice them. We just take them for granted. And these senses are absolutely critical tools. Temperature, for instance, warns you about a hot stove, but it also gives you comfort, like wrapping up in a warm blanket. And touch? Well, it helps us move through the world, but it also allows us to connect with each other through something as simple as a handshake. They are essential for our survival for sure, but also for our society. Which brings us to the big, crucial question. How does something physical, like the heat from a flame or the pressure of a handshake, actually get turned into a message that our brain understands as hot or firm? There has to be some kind of translator in there, right? And that brings us to the next key part of our Nobel-winning phrase. So, how does it all work? Well, it's all thanks to some amazing biological hardware we have. And that hardware is called receptors. These are the tiny, microscopic heroes of our story. So here's the bottom line. A receptor is basically like a tiny specialized doorbell on the surface of our cells. When a very specific thing comes along, like heat or cold or a bit of pressure, it rings that exact doorbell. And that ring, it's not a sound. It's a tiny electrical spark that kicks off a whole chain reaction. And this shows that pathway perfectly. First, something happens. Let's say you touch a piece of smooth glass. Then, step 2, the specific receptors for that kind of pressure get activated. Step 3, those receptors fire off an electrical signal that just zips through your nervous system. And finally, step 4, your brain gets that signal and says, aha, that's smooth. It's an unbelievably fast and elegant system. Okay, so who were the brilliant minds that figured all this out? For a really long time, scientists knew this process had to be happening somehow, but they had no idea what the exact molecular machinery was. Pinpointing those specific doorbells for heat and touch, that's the monumental achievement we're talking about. And it belongs to two incredible scientists. First, you've got David Julius. He was trying to figure out how we sense painful heat. And he had this super clever idea. He used capsaicin, the stuff that makes chili peppers feel hot, because he knew it triggers the same pain sensors as an actual burn. So, by seeing which nerve cells reacted to the capsaicin, he was able to hunt down and identify the exact protein, that one specific receptor that was yelling hot. He found our body's burn sensor. And then we have Artem Patapoutian. His goal was to find the receptors for mechanical stuff, like pressure and touch. His team's approach was just painstakingly brilliant. They took cells that they knew would send an electrical signal when you poked them, and then, one by one, they turned off individual genes until, poof, the signal stopped. The gene they had just silenced, that was the recipe for the pressure sensor. His work unlocked how we feel everything, from a light touch to literally knowing where our arms and legs are in space. So when you start putting all these pieces together, the senses themselves, these incredibly specific receptors, and the scientists who finally found them, you end up with something so much bigger than just the parts. You get a complete blueprint for how we feel the world. And this is the real scale of what they did. They didn't just find a couple of missing puzzle pieces. No, they revealed the molecular architecture of sensory perception. And that word, architecture, is so important, so deliberate. Because think about it. An architecture isn't just a random pile of bricks, right? It's a grand design. It's a plan. Their discoveries gave us the fundamental parts list, the blueprint that our nervous system uses to build our entire sense of reality. This gives scientists a foundational framework to now tackle enormous challenges, like finding new ways to treat chronic pain without addiction by targeting these very receptors. So let's look at this quote one last time. It's not just a string of words anymore, is it? We now know receptors are those tiny, specific sensors. We know temperature and touch are our vital links to the world around us. And their discoveries, well, that was the moment they unveiled the actual architecture of how we perceive everything. And that leaves us with one last really powerful question to think about. When you finally understand a blueprint, that's the first step to being able to repair or even improve the original design. So now that we have the architecture of feeling, what comes next? What new treatments for pain, what new kinds of technology, what new understanding of ourselves can we finally start to build?